In this video, let's take a look at a sample survey that we include for least squares network adjustments. So I'm going to open up the sample survey folder and just show you that it's this one, Ghilani example 16.2. And there are 3 files with it. I've got one that is a backup file here. I'll just delete that real quick. And I'm going to go ahead and open up this PDF file for it and bring that over so you can just kind of see what the example is. We've copied a couple of pages out of Ghilani's book, and this one is a minimally constrained network. So we're going to start with a fixed position at Q. We're going to use pretty much a fixed azimuth from Q to R, and then we're going to take all of the observations we can for angles and distances, and we're going to end up with sort of a matrix of data here. These are the different distances we can measure with their estimates of standard error. Here are the different angles we can observe, again, with their estimates of standard error. And then we're going to throw a really low estimate of standard error on that azimuth and basically fix it. So we're going to start with the fixed point Q and the fixed azimuth from Q to R, and everything else is going to be free to be solved. And then in the PDF, we also give you the solution. So here are the adjusted stations. You can see how much they're adjusted in both the X and Y direction. Here are the distances with their residuals, the angles with their residuals, and standard deviations. And then, of course, we're going to look to see that our reference variance is 2.2, and we passed the chi-squared test at the 99% confidence interval. So let's just jump in and take a look at this survey real quick. I'm going to go ahead and open it by going to Sample Surveys and picking the Ghilani network. So here we've opened up that survey, and I've got the coordinates that I've held for the positions here. I'm just going to open that up real quick. So I've got QRST in here. And I actually put the coordinate values in that Ghilani gave. And I can't remember if I used this R2 or not for that fixed azimuth. I can't remember if I put in an observation to it or not. And Q is protected, so it's going to be kind of bolded coordinates. All the rest of these are not protected. And then I used this traverse observations and told traverse PC to go ahead and enter all the distances and angles. And I did 3 records here where I recalled the occupied point but in the back site, and then I used an observation record, but I could have just said equals RSTQ as well. So that would have been just fine. If I don't do RSTQ, I don't have to have separate point labels. So this allowed me just to keep it simpler by recalling those points. And you'll see in a minute when we edit the data, it helps me keep track of the estimates of standard error. So here's my traverse for all those observations. And you can see it looks just like what Ghilani had in his example here. There we go. So here's his network example here. Let's go ahead and bring up our least squares. So I started out by analyzing the survey, and that brought in all those points and observations. And you can see then that Q is the only point that's fixed. All the rest of those are free. The other points can be adjusted with the least squares. And then I want to go in and show you how we edited the observations here. So we went into Ghilani's data here, and we said he gives us estimates of standard error for each distance and for each angle, and then for that azimuth. So if I see one that's common, like the 4.0, I could set that in my a priori values. So I could come in and say, okay, let's go to miscellaneous a priori values, and I can set up the 4 as the standard angular error if I want, and put as 4 as the pointing and 0 for the reading. And I can use the standard distance error, but I pretty much had to edit each one of these to match Ghilani. So I put in the value, selected the distance or the angle, and then set the precision. So all of these match Ghilani. You can see here's that azimuth matches his. If I take a look at R to T distance of 0.37, here's R to T. Well, that should be 0.30. So let's go ahead and just correct that here. So R to T is 0.3. Show you how we do that. So R to T, so I'm going to do a 0.03 and then set that precision. Okay, the rest of them I know I matched up because I did all of those. And then here are, most of those angle precisions were 4 seconds, but some of them were 4.3, 4.5, 4.7. Okay, so now I've got everything matched up the way Ghilani did. So I'm going to solve this. I'm going to choose the 99% confidence interval. And I'm going to solve it. So it passed the chi-squared test at the 99% significance. And let's go ahead and do our report here so we can just kind of track through what Ghilani gave us. So here are my stations. Q is fixed. RTS are free. Here are my angle observations with those precision or estimates of standard error that he gave us. Here are the distance observations, again with the estimates of standard error. And here's that azimuth that we basically fixed. Okay, so the first thing I want to do, since we're comparing this with Ghilani, is take a look at what we computed for our statistics. We computed a reference variance of 2.2 and a reference standard deviation of 1.49. So let's drop into his results. Okay, so here's his reference variance of 2.2 and a reference standard deviation of, he does 1.5, but we've got more decimal places, so we have the 1.49. And then we break this into the components. So I could say, well, it's not the coordinates that are producing the error, it's really the horizontal components or observations. And once I get to the horizontal observations, I can say, looks like it's really the angles that are producing the bulk of the error, not the distances. So I'm likely, if I needed to come in and improve my data or my stochastic model, I probably would look at angles now, and certainly not azimuths, probably not distances, to see what I got. And then, of course, we find out that it passed the chi-squared test at the 99% confidence interval, and I can come in and take a look at my chi-squared and where it fit in, and again, compare that with Ghilani's information. And then I can simply come down and say, okay, here are my adjusted coordinates, the standard deviations, and I can go back and compare those with Ghilani. Here are my angle observations, my residuals, my standard deviations. Here are my distances, again with residuals, standard deviations. And I can go back and just say, how does all that line out with what Ghilani had here? And am I close to what he had for these different residuals? And you'll see they're pretty much spot on. So a good example out of the Ghilani text, and we provide that as a sample survey for you in TPC Desktop 2021 R1.